Fragments is a game on the HoloLens where you are the star of an interactive crime drama where you use your cunning to solve authentic mysteries that take place in your world. To really feel like you are the star, you're not playing a character, you're not somewhere else. These mysteries are actually brought into your space, your living room, your kitchen, your bedroom. So the more immediate and the more natural we can make the interactions with the characters in the game, the more it'll innately feel like it's about you and it's not about somebody else.
The scan you just completed will allow the NIU to place fragments of memories in your world.
As amazing as the game was, placing evidence in your world, moving this AI character around your environment, all the actual people in this story, Ruth, Kirkland, Sarah, Sam, they all took place behind a holographic screen on the wall. We realized that we were missing a huge opportunity to immerse the player, especially in connecting the player with these cast of characters that they solve crimes with. So we went through an ideation process with our partner Asobo to develop an alternative to this glass wall that we had developed. We came up with ideas like a holotube, a magical robot that would follow you around, an octagon where characters could exist in the octagon. We went through a ton of things until Asobo came to us and said, hey, we have this amazing tech we're using for Conquer. We understand what a couch is. We understand what a chair is. Why don't we actually bring the characters out of the wall, put them in your world, we'll call it the Holo Call, and players will feel immersed and have natural conversations with these fictional characters.
This is Sarah Barnes, our biotech and forensic analyst.
Nice to meet you.
As we were developing the HoloCall, we started to really call it our campfire moment. It's that moment where the player is gathering with the team and kind of understanding what the mission's going to be.
Please help us. Help us bring a little baby boy home again.
The amazing experience about having these digital characters standing around this campfire is that the natural motions, the natural movements of each character in terms of gesturing, eye contact, where they're looking, would guide the player to look exactly where we want them to look. And this is really key because in a mixed reality scenario, when you're putting digital content in your room, it's something that you really want to make sure that they're not looking at a screen where you have this real estate sitting in front of you. That real estate is 360 degrees around you. You have the entire world as your palette. So it's very important to make sure that the player knows where to go, where to look. And in the case of the HoloCall, we just relied on natural human interactions to do this.
Here, it seemed to prevent the system from getting a lock on him.
So we're hunting blind. That leaves us with only one lead, Dr. Jacob Baker.
One of my favorite Fragments moments I got to experience in having worked on the title was the difference in playing the game at work and playing the game at home. So there's a moment in the game where the villain actually hacks into the machine and threatens you. And I actually was directing the mocap for this. So this is something that I was very familiar with. I told the actor, you know, make it look like you're actually seeing the player's room.
You must have a very nice life.
I play that at work, I take it home, suddenly the character is standing on my floor in front of my bookshelf in my living room. He gestures to my house and threatens me, and my heart actually skipped a beat.
Look at you. Big damn hero.
At that moment, I realized where we were taking entertainment with HoloLens. It's something that people just haven't experienced. The minute that you have a digital character in your immediate space, it's not about being in the world. It's about this character being in your world. And having that happen in my house was something that I'll never forget. And it's one of the reasons why I'm so excited about where developers are going to take entertainment on HoloLens, because we're going to be able to tell stories and have people feel emotions that they've never experienced before. And that is incredibly exciting.
So, a little bit of a primer for what we're going to talk about and kind of how we're going to look at things. As we go through this stuff today, I want you to kind of think about that. Okay, good. Let's kind of set some context. Now, full disclosure. In the description,
Lego Friends sets. It's a beautiful day outside
in the description
Heart
of
Lake
this
City.
session,
Let's have some fun before the beach party. Smoothie.
well, I closed the wrong browser window. Well, you know, stuff happens. When we were setting stuff up for Games Week, we submitted different sessions to different things. Submitted sessions to Unity's Unite Conference, GCAP, PAX, all kinds of stuff. And you may have noticed that the title for this session is something that really plugs Unity, right? HoloLens Unity. because that was supposed to be in the Unity conference. However, we will be talking about that, and when it does come together. The other thing is, if you notice my title of the video, I need business development manager. I actually do more holographic app design and help customers figure out how you're going to use this thing. What can you do with it? What do you have to consider? How do you make sure it's sit on a chair? What does that mean? I don't do a lot of the C# coding, so I want to talk a bit about the things that I believe are actually a little more important. Because how many of you do coding and coding? Coding is syntax. Syntax can be learned from place, right? Syntax can be learned from example. Design, though, is a little trickier to slow down. So I'm going to focus a lot on design and how this all ties into Unity and how we've developed open source tools to help you write these cool apps in Unity. So we're going to try to do probably as many things as we can to make it so you can just absorb a lot of our open source code. So when you're writing the apps, you don't start from scratch. Okay? All right, so what is it? Building apps, Windows Mixed Reality. You notice that the overview of the hardware is grayed out. How many of you saw my session last year? Okay, maybe I will cover the hardware a little bit. But if you've been following HoloLens and what we're doing, we're in this world of what we call Windows Mixed Reality now. We're not just talking about holographic or Windows or HoloLens. It's now Windows Mixed Reality. We want to kind of set the stage a little bit for what that is and how it works. Use the mics. I didn't want this recorded anyway, so you know it's okay. He thinks I'm kidding. He didn't want to record. I'll use the mic. Apparently, and it's recording from that camera. Hi, I'll talk to you. See how you see yourself in the video. Obligatory logo shots. Okay. So that's that step that we went from beyond HoloLens to this mixed reality world. And a lot of people ask what's the difference or why, or what's different than VR. When you look at the new headsets that have come out, they are very VR style devices. But if you see the ones, and I'll show you pictures of them in a minute, they have sensors in the front. And so same sensors, those same environment sensing cameras that the HoloLens uses to create surface reconstructions to know there's a wall here, for example. So you'll still be able to take advantage of that even in a VR style scenario. So you can have a VR environment and still show the physical walls of the room they're in if you want to. Okay? So what makes this different? What is that difference? Now, how many of you have already figured out the difference between VR and AR and MR? A couple of you. Oh, that's good. That's actually good. The message is getting out. That's wonderful. People often refer to HoloLens as as AR. Not quite. A little more than that. And I'll explain how this works for the 4 of you that didn't get it. We live in a physical world, and we're all used to operating in this physical environment. It's the things you can see, hear, taste, touch, smell. But on the other end of the spectrum is a digital world, which is the VR-style world, entirely made up of logic and digital bits and rules that live in a computer. But everything in between those two things is some degree of mixed reality. As soon as you take a digital asset and have it interact with the physical world, or have a physical thing interact with a digital asset, you're in some degree of mixed reality. And AR is a subset of that. Right? The difference is that AR tends to be two-dimensional and tends to be a fixed pane in your field of view, and it provides information about the world around you. You can even pull in IoT sensor information and show what the cameras are recording or whatever, but it doesn't integrate or interact with that world. It's not environmentally aware.
Whereas a mixed reality device knows that there's a physical surface here. There's a surface there that it can sit on, or they can crawl under and hide behind. That's the difference. That's the MR difference, is that environmental awareness. So when you design applications and games going forward, you want to consider if that's the environment you want to be in, or if you need a VR environment, because it's really a right tool for the right job kind of scenario. We don't consider HoloLens to be a competitor to VR. It's a different tool for a different job, right? So if we look at that spectrum, I mean, I'm just going to put this on the screen. This build is way too long. Come on. One more. Okay. Good. So if you look at these immersive headsets, we call these like IMHDs, immersive head-mounted devices, which are all the ones that have come out recently from Acer, Dell, Asus, and Samsung. Samsung just announced theirs, which is like the Ferrari of these headsets. It's really cool. They do have the, oh man, it's okay, forget it. It's all right. They are VR, it's a VR style experience. And how many of you were at the Unite conference, at Unite conference? Did you get to try it? We had it running up there. You didn't? So it's pretty cool, because the one you were in, when you do the Halo shooting stuff, right? When you start walking to a boundary, it tells you, hey, hang on, don't go past here. It's actually registering the physical wall and the physical edge of the stand. So you can do that and have that restriction without having externally placed cameras. You don't need to rig a room or mount cameras or anything. You just put the device on, and now it's aware of the physical environment. So you could guide people down the aisle between the chairs and things if you wanted to. So that's that one step, kind of like where virtual reality slides one stage closer to physical reality by helping blend those things together. And as you saw in the Fragments video, they're able to sit characters on your couch. They can walk around your room. When they hang a mirror on the wall, they hang it on your wall. The character was standing in a hallway and looking into another room, right? Imagine the immersion that creates in a player. That's kind of a cool moment. You know, it's one thing to be in VR, and it's very immersive. VR is a very immersive scenario. Really good for simulations and some training and things like that. But the ability to break out of the screen, break out of that environment, and then bring the game to their house, that's cool. That's that next level of cool. So we've got the devices, these things that are kind of crossing paths. Now, at some point, all devices are going to do everything. You know, the way the technology is going, the way the advancements in lenses, batteries, processors, remote power transmission, eventually all these devices are going to do all this stuff. But right now, this is kind of the state of play we've got. So we've got, that's a very pretty build. Okay. So we have these different devices in these quadrants, and you have to consider when you're writing your games or even applications, they don't necessarily have to be games. What do you want to target? What do you want your user experience? Where are they going to experience your game? Now, if you want somebody to be able to walk around and do stuff down the streets of Melbourne, if you're okay with them being stationary when they get there, you can use the VR devices, everything from Google Cardboard up to Samsung Gear VR. You need the portable ones, phone-based ones, right? That's pretty cool. In fact, I did the Unite conference in Korea, and they were handing out these little frames. That basically what you did is there was these two lenses that you snapped in one end of the frame, and there was a pad on the other end with a clip, and you just kind of snapped it on the end of your phone. It was like the most minimal VR piece of kit I've ever seen in my life. It didn't even cover up the outside. It was just this little thing that held it at the right distance from your nose. It was kind of weird, but I mean, it worked. You know, it's like 4 cents for that thing. If you need somebody to have really high resolution display, really powerful information processing, and still be interacting with their physical environment, you might need to go with these feathered see-through devices, right? This Tia's not Tia, it's something else, but Tia's a Zachary helmet, right? And they use these in mine sites and construction sites to pretty much augment what the people are seeing. It's not, It doesn't have environmental awareness, so it is an AR-style helmet. But if you want the fragments experience, you need something like HoloLens, or something that will do that kind of thing, where it's very environmentally aware and it can place your digital assets in that environment. Now, the Windows mixed reality headsets are more the VR stuff. It's more VR. Some of them, you can tell there's walls and obstructions in the room, but you don't get the visual. Right? There's no RGB camera on there that's feeding you a video of what's around the user. Like, any of you ever work with the Leap Motion? Strap it on top of the Oculus? Yeah. So that was basically a camera that you could do hand tracking. You could feed information into the display. The IMHDs don't have that yet, but they are environmentally aware. They do have the environment sensing cameras. Now, there isn't a clock in here except my watch, so keep me honest, okay? Right. What is it? What is it? The thing about HoloLens, and people say, oh, it's a cool-looking device and all that, but it's very expensive and things. I mean, it is, but there's a reason, a couple of reasons. The HoloLens is actually a fully self-contained Windows 10 PC. It has CPU, it has GPU, it has its own RAM, its own storage space. Everything is in that. It's like a laptop wrapped around your head with holographic displays. Yeah, it's expensive. 4,386 some odd Australian dollars for the dev kit. But let's say you want to go out and develop for HTC Vive. You're going to buy the Vive. Ching. Now you got to buy a computer to run the Vive. You're in the same ballpark, right? So that's kind of why it's priced at where it is. It's also kind of unique. I suppose you can go buy the other fully self-contained Windows 10 holographic computer, but I can't think of one off the top of my head. There is that, right? With the head-mounted devices that have come out, the new ones, we're starting to see that commoditization of this, and you're going to see more of these coming out November 6th, in time for Christmas, and these will start becoming more and more mainstream. And the more mainstream it gets in consumer land, where you're going to be having your games playing, the more you have to start thinking of how are you going to translate this and where's it going to go. And that's what we're going to start talking about, developing for this stuff. This is a mixed reality example. This is where we have a game asset standing on the table next to us. Legendary Entertainment did this with the World of Warcraft movie. They had a few HoloLens devices on the red carpet, and as you walked up, you could put it on and see Ogrim and all these guys standing there with you, and you can talk to them and give them a fist bump and all this. It's a cool experience. It's really involving the players and the users and the people who are going to see the movie in that experience. And the fact that you can do it while you're standing on the red carpet just adds to that. I didn't have to have the VR stuff on. There's a few main areas that we've been talking about for some time when it comes to MR and how this whole thing sticks together. Gaze, gesture, and voice tend to be the default interaction model for HoloLens. Now, you've seen the controllers in that second video, the lady and all that. Those are the new controllers. We call them 6 degrees of freedom controllers. They're a lot like the ones that Sony had with the PlayStation, but there's kind of more bells and whistles on them. Those controllers, we've designed and produced them, and you notice that all the headsets that have come out for Windows MR have those controllers. So it's kind of a common controller structure. So when you write for this, you will understand what those controllers are capable of, and it'll be consistent no matter which device the user has. Okay, so you won't have to write a different set of controllers and drivers and hooks for, say, the PlayStation ones or working with a Kinect or something else. You can create it once, and when you do the controller motions, it'll be the same across HoloLens, Surface, and head-mounted displays. Okay. Now, Gaze is the default targeting model, and it's very natural. And when you're designing applications for this, you have to consider that, because people don't have as good a fine motor control over their head as they do their fingers. If you're trying to have them target something, if it's a fast-moving object, they have to track it with their head, not just their eyes. These devices don't have eye tracking yet. So they'll be turning their head to try to locate stuff. Now, if any of you tried a HoloLens and played Robo-Raid, that's what we have. There's little robots where we punch a hole in the wall and make a tunnel, and these robots come out of the tunnel and they start crawling on your wall and your furniture and the people hanging out in the room, and you shoot them. You have to look at them and shoot, either with the clicker or a tap. All the games and things we've designed that come with the HoloLens are designed to train you to do certain things. And you might want to consider this when you're building your apps and your games. In your intro levels, in your training, in the beginning of the game, get people to practice things that you need them to do. For example, look down, shoot down, right? Look here, tap, or click, or whatever you're going to do with controllers. That practice will go a long way towards making them not hate your game. Right? So, Fragments is designed to get them to understand interacting with the environment. RoboRaid is designed to get them to practice look and shoot. Right? And then Conquer. Young Conquer is the one with the, what is he? He's not a squirrel. He's some kind of rodent thing. That jumps around in your furniture and collects coins and crawls under your table and stuff. That's designed to show you that you can hide things and how you might have to look around. Use hooks that get the user to go places you need them to go. In most of our videos, you'll see a dog. That dog's name is Fang. And Fang used to have a very specific purpose. When the HoloLens scans a room, or when any of these devices scan a room, it builds this surface reconstruction of all the surfaces in the room or environment that it can interact with. But it's not X-ray vision. It can't see behind things. A table with a tablecloth appears as a rectangular block, and everything behind it is, block. So what Fang would do is Fang follows you around your house like a pet dog. And if the HoloLens noticed there was something in the room that it didn't know about or didn't have the full surface reconstruction done, Fang would come around the corner and start barking at you and play hide and seek. And Fang would run around behind this thing to get you to go after him, so you'd do this. And give the HoloLens a chance to look behind it so it could finish mapping what was behind that. Right? Use tools like that. Use little hooks that it seems natural. Chasing a pet around the house, playing hide and seek, it seems like a natural interaction. But be aware of that. The more you do things in somebody's home, in their environment, the closer to natural you need it to be. Now, I'm not saying you can't make things look like cartoons, right? But if you're going to do that, commit to that style, obviously. But, having arrows pop up and go over here, that's a little goofy. Try to entice them in a way they're not realizing they're being enticed. Gestures, we've been talking about that, and voice commands. Now, the voice commands for HoloLens, it's based on Cortana. The Cortana does the interpretation, and you can program pretty much any voice command you want. We've had people that wanted the device purely for a heads-up, hands-free computer that they could control with their voice. That's great, because okay, this is kind of a random thing, but there was an insurance adjuster, and he was controlling these other adjusters, and they all reported to him, and he had one specific problem he was trying to solve. After a storm, all these insurance adjusters would go to people's houses, they would put the ladder up against the house, they would climb up the ladder and take pictures of the damage of the roof on the house. When they were taking pictures, they'd fall off the ladder because they weren't hanging on properly. All he wanted was a head-mounted, voice-activated camera. They can climb up there, hold on with both hands, and say, take picture, take picture, take picture. And you can use the RGB camera to capture those images. So, think outside the box. Now, spatial mapping I've mentioned several times. I call it the surface reconstruction. What this is a collection of planes and colliders that you get to interact with in your games. Now, this is mapped in near real time. So if we're looking at these chairs, for example, the device looks at it, makes the surface reconstruction using its spatial mapping, and then if I move a chair, it makes a void there and puts the chair over here. So if I drop a holographic ball, it will bounce off the chair, roll on the floor, and we can kick it around. If I move the chair and drop it, it'll go straight to the floor. So you can now operate in somebody's home or some environment in near real time. They can move things. Now, this is one of those tricky design things that come up that people don't think about. Let's say we have a holographic water glass. If I have a holographic water glass and I put it on a physical table, it'll sit there nice and pretty and it'll do what water glasses do when you leave them alone. It'll sit there. But I'm wearing my HoloLens, I leave the room, and I go wandering around. And while I'm gone, somebody comes in here and they take the table out of the room. When I walk back into the room, what happens to the glass? It falls. Okay. Right. Right. So these are all perfectly legitimate answers. Now, how do you code that? Right? See, because how many of you have done the ragdoll physics thing where you walk in a room and you want things to appear they fell naturally, so as soon as the user loads that scene, everything falls over. That kind of looks goofy, doesn't it? You walk in a room, everything falls over. So the HoloLens wouldn't know the table's gone until it gets a chance to see it again. And if you take that approach, the glass will go boom and fall when you walk in. There's an easy solution to this. You don't display the glass. Oh, that sounds funny. Not really. I assume that the glass went with the table. Right? Those kind of design decisions are things we have to deal with now in an MR world. And we've never had to do that before. Even in virtual reality, nobody takes your table unless you let them. And if you do let them, you know exactly what you're going to do with glass. So the real world is a chaotic mess that we have to deal with now. But it's a fun challenge to have. So when you're dealing with stuff like that and you're working with your surface reconstructions, think ahead. Think about that kind of stuff. World coordinates. I'm going to talk a little bit about world coordinates in a minute. Spatial sound is another one that you really want to take advantage of. You're all familiar with surround sound. Everything touts surround sound. 5.1, 7.1, but there's like a 10.1 now and stuff. But surround sound tends to be a 360-degree plane on the level of your ears. And with the new Dolby technologies and stuff, you have about a 5-degree swing you can do with surround sound without moving the point source, with moving the speakers. Which is still cool, and it's fine for home theaters, headsets, most gaming. But when you're going to interact with a physical environment, when you're going to have your applications and your games work in a physical room, and you want something that can climb up the wall and crawl across the ceiling, you don't want it to sound like it's here. It needs to sound like it's up there. So the spatial audio system and all of these Windows mixed reality devices, in the Windows SDK we call it Sonic API. It's designed to work with the way the ears operate and kind of play some tricks on it. I'm going to play a video about that in just a minute. But we can actually make sound go up over the user's head, and you can track it with your eyes closed using echolocation. So it's pretty cool. Take advantage of that. That's a great question. Yeah, so the question, for those of you watching this later, the question was, can the spatial audio represent reverberations and echoes in different environments? It would work the same way you do it in Unity now, which is to say a little bit complex, but workable. It's not really designed to handle echoes and stuff like that. It's more designed for point sources, point sound. And even the way you hook it up in Unity is you have an object, you add a sound behavior to it, and you give it a sound, and there's a little tick box that enables spatial audio, and you tick that box, and now we handle everything else. That's right. Yeah. Yeah, and that's a really hard problem to solve. Of course they did. Yeah? Mm. Okay. The HoloLens does not have that kind of power. There's probably something in the works that I'm not privy to, but yeah, not in its current incarnation. Yep. You could, but see, now you're talking about some fairly advanced math, right, doing reverse raycast and things like that. And you want to be careful with these. Now, the immersive devices, these on the bottom row here, sure, go for it, because they're plugged into a PC. And you could have 4 NVIDIA 1090s, 1060s in there or something, and really, use the GPUs and do it. Sure, go ahead. HoloLens, battery operated, head mounted computer, not so much. Well, the head-mounted devices don't have camera. They have the environment sensors. So you can't really tap into the stream for that, no. The HoloLens, though, you can get the video and the RGB stills and stuff off the camera, yeah. And you have access to the surface reconstruction, too. Yes. So the SR itself is actually something that the HoloLens or these devices continuously build. Like if you're wearing a HoloLens, for example, it's not so easy to do this with the head-mounted or the IMHEs. But with a HoloLens, I can walk around here and scan this room, and as I walk out the door, it just keeps adding to its surface reconstruction, and eventually would map the whole convention center. Right. Yeah. Yep. Yeah. Until it runs out of allocated memory for the SRs, then it starts overwriting. Do the old ones. Yeah. So what it does, it is safe to disk. It is persistent. The SR is persistent. And you can even extract it from the device, and you can download it to your PC. So if you know that you're always going to do something in this room, for example, walk around here, scan it with the HoloLens. Then when you plug it back into your PC, or even over the wireless, you pull the surface reconstruction off, load that into Unity, and now you have the SR to work with, and you can actually position things very well for this room. So when you save that and load that and that scene comes up, it already knows where things have to go. Now what the HoloLens will do, let's say the first time you came through here and you did this, and we're kind of getting in the weeds, but that's okay. You scanned it and all the chairs are in here. And when you come back, the chairs are gone. It'll take a couple seconds we call it healing the SR. It will say, oh wait, those chairs aren't there anymore. Let me flatten this out and go to the floor level. So it takes a second to adjust, but it starts from a known position and then adjusts where it has to, instead of rebuilding the entire SR. That's pretty inefficient. So not by default. The SR by default is just it's basically like a point cloud and stuff. But if you wanted to do that, you could turn on the capture and then have it capture so you could match the RGB stream to the SR, but that would be like a post-process thing you'd have to stitch together. Right? So you do have access to the visuals, but by default the SR is not the RGB. Yeah, pretty much covered. So, multiple devices. One of the things we did a little while ago, a week or so ago, we released a Windows 10 Creators Update. And the Creators Update is designed to start commoditizing the creation of 3D images and holographic images and assets. You may have seen the videos and the news about Paint 3D. Well, Paint 3D is really created for people to start creating holograms for themselves. You can draw a circle, tap a button, and now it's a sphere. That sphere is hologram ready. You can transport it, you can load it in a VR system or anything that's running the Windows Mixed Reality system and have a holographic sphere in place wherever you put it. You can add a cylinder and a couple spheres in a box and make it a duck, and now you've got a duck, right? So not everybody out there is a really good 3D modeler. So there's going to be some goofy things, but there's already a store for it. And you know, there's things about creating pictures and images and taking your videos and plugging in holographic assets or 3D assets into your own videos and doing all this stuff. And that's kind of what the Creators Update was designed to do. But the Creators Update also had all the libraries and drivers for Windows Mixed Reality. So devices that have an environment sensing camera in them, the new Surface Book, Surface laptops, and things like that, can look around, can understand the environment, and you can take your Unity-based holographic applications and look at them through a tablet or a PC. A lot like the way Vuforia works when you have a QR code that pops up a 3D image, right? Except you don't need to have a QR code or any markers. The device will just understand it. And When you create things for Windows MR, you create them once and you get all of these devices. You can run them on everything from some of the phones that are going to be running this up through Xbox, all the head-mounted devices, HoloLens, and even the Surface Hub will run your applications and your games. Okay? And it is actually a write once, run anywhere. That tagline kind of got a bad rap for a while, but we are working towards that. And you can do all this with familiar tools. Right. Unity is our primary dev environment. We've been using Unity to develop holographic applications and things like fragments for almost 5 years. We work very closly with them. Our coders contribute to the Unity code base and vice versa, and we're putting the Windows holographic stuff in there, and so we have a pretty good relationship with them. If you prefer, you can write DirectX 11, DirectX 12. You could get in there and hand code it, write your C++ and go for it. Now, this is like games middleware. For the games middleware, that may be where you want to go. If you've got back-end processing or AIs or something like that, you may want to write it like that and load it in there. We kind of went with Unity because the tool set for Unity is pretty good. When you're in the Unity editor, it's almost a Visual Basic like drag and drop, add a behavior, click, add a script, boom. Now it's a singing, dancing, whatever. That made it easy and approachable to create these apps. Because when we started looking at this and we said, oh, HoloLens is kind of a commercial targeted device. And commercial developers don't understand 3D models and textures and frame rates and stuff. Let's give them Unity. Let's get them into that. It was a little easier for them to approach. But like I said, if you want to go DirectX, go for it. It works just fine. Now there's several things that you want to do. You need this is basically the set of required software. If you don't want to use Unity, you can use DirectX directly, of course. But the simulator or the emulator is actually incredibly good. So you don't need to buy a HoloLens. You don't need to necessarily buy one of the head-mounted displays, although they're pretty affordable. The emulator was created before we had hardware to work with. So the guys that were writing the chipset for the holographic processing unit. Do I need to explain what the HPU is? Holographic processing unit? I thought you should. Okay. There's 3 chips inside the HoloLens. There's a CPU, a GPU, and an HPU, a holographic processing unit. In a lot of these systems that you see out there, they try to do everything on GPU if they can, or CPU if they have to, and that really weighs those 2 chips down. But we knew that we needed certain levels of performance, and we needed to handle the SR and these gesture recognitions and all the stuff coming off the optics of the device. So we invented a new chip called the HPU. The holographic processing unit has 3 main jobs. It does gesture recognition, so it looks for skeletal tracking and handles all that. It takes a couple million sensor readings per second off the sensor array and processes those for the surface reconstruction and the orientation of the device. And it maintains holographic placement to millimeter accuracy. So we have dedicated a chip for all of that kind of processing, which leaves a lot of the CPU and GPU for you to use. So that's kind of what this HPU is. Where was I going with that? Oh, the simulator. Before we had the HPU, before we had the Veil and the stuff to use it with, we needed to start writing apps and start writing OS. So we basically did simulator-based development. The simulator it mimics the hardware to a T. So if you download the simulator, you get that running on your machine, if whatever you build in the simulator, I almost 100% guarantee, 99.9999 guarantee it's going to work just fine on the devices. Okay, so if you can't afford to grab a device, work with the simulator right up front. So here's a couple key things you want to look at when you're doing this. One of them is hologram comfort. Now this is going to apply if you're doing VR, AR, MR, anything where you are directly piping things stereoscopically into a user's eyes. You need to consider some of these points.
Have you ever gone to a 3D movie and gotten eye strain, a headache, nauseous? Why does this happen, and how does it apply to the world of HoloLens? There are several things going on when you view stereoscopic 3D content, all related to your eyes and how your brain is interpreting what they see. The first factor is accommodation. accommodation is the ability of your eyes to focus on an object as it changes its distance from you, similar to the way an SLR camera works. If the camera is focused on the foreground, the background will appear blurred. Conversely, if you focus on the background, the foreground will blur. Your eyes work in a similar way. The second factor is vergence. As an object moves closer to you, your eyes slowly converge. As the object moves away, your eyes diverge. Lastly, vertical disparity refers to the vertical alignment of the holographic images relative to the user's eyes. If the device is slightly tilted, then each eye is looking at the image at different heights. To bring the images together, one eye strains to look up, while the other strains to look down. When viewing holograms, your visual system gets conflicting distance information on where to focus. Vergence and accommodation are sometimes in conflict, leading to a strain on your eyes. Designers and developers can help make holograms more comfortable. Our research found that holograms are most comfortable at 2 meters. Holograms closer than 1 meter can cause more vergence accommodation conflict. Distances further than 2 meters cause somewhat less conflict, but you still want to keep most of your content within the zone of comfort. No sets of eyes are the same, and no two experiences are the same on HoloLens. What is comfortable for you may not be comfortable for others. We encourage you to read and follow the guidelines to make sure that the HoloLens experience is enjoyable for everyone.
Of course. Yeah, skip that. Okay. Couple things to note in there. If you're designing for VR, you have the same issues, right? If you get the device on and it's sideways or crooked, it hurts. It gives you eye strain. A lot of you are going to want to create your games. You're going to want to demo your games to somebody. You're going to want to buy them or get a publisher or whatever investment. Your demos are very important. Be very careful with how you fit the device on someone. Make sure they are comfortable. Make sure they don't come out of there cross-eyed. The HoloLens kind of magnifies this issue because of the way we work with the natural world. Because it's a transparent device, we don't tend to have a motion sickness problem. The holographic frame is designed to preserve your peripheral vision. So just like walking around looking at your phone, you don't get nauseous or motion sick, and you can pretty much navigate without running into most things. Have you ever seen the intersection in Japan where everybody just goes for mad like that? And they're all on their phones? Only about 1 in every 10 people crash into each other there. But now, anyway, that visual disparity is what makes people sick. VR has this issue more often than not because, I shouldn't say more often than not, more often than some other systems, because what your eyes are telling you is different than what your inner ear is telling you for balance. The roller coaster thing can make people very nauseous, and if that device is a little bit out of whack, even the most stalwart Air Force pilot will get sick on you. So be careful with that. Make sure when you give a demo of whatever you're doing, you consider comfort and the eye strain in the device. Now a little bit more about the sound and how this kind of sound thing works, okay? They explained it fine. I don't need to repeat what they did.
When the lights go out, we rely on our sense of hearing to tell us what is going on around us and keep us safe from danger. Humans develop their audio system to judge distance and direction of people and things beyond our line of sight. Similarly, in HoloLens, we use spatial audio to expand the mixed world experience beyond our visual senses. HoloLens devices have a field of view directly in front of the viewer. Holograms can only appear within that line of sight. But the speakers on HoloLens use HRTF, or Head-Related Transfer Function Audio, to simulate sound coming from distances and directions. This makes the mixed reality environment more realistic. Our ears help us judge the distance and direction of a sound by interpreting how it reaches our 2 ears. HRTF audio simulates the same thing. Left or right audio cues come from differences in the time at which sound waves arrive at our 2 ears. Up, down, front, and back cues come from spectral changes produced by the outer ears, or pinna. By designating where the audio is coming from, the HoloLens speakers simulate the same experience of the sound, arriving at different times to our ears. The spatial audio capabilities of HoloLens provide developers with a lot of functionality. You can change where an audio source is on a frame-by-frame basis. You can play, stop, pause, resume, loop, and fire and forget sound assets. By taking advantage of spatial audio, developers can greatly expand the mixed reality world of HoloLens.
Okay. So we really have worked with every way the human body hears sound. And the speakers on there emulate that and can reproduce that. So sound can be very immersive. You also need to take advantage of it. If you have a situation where things are going behind the user, behind the player, and they can't see it or might forget it's back there, make it ping or chirp or bark or something to draw their attention to it. Okay? You can always use stuff like different levels of affordance, like the arrows, a little targeting reticle. Like if you've played Robo-Raid, there's a targeting reticle that always points where the alien is you can't see. You just follow the line, right? But sound is a very natural way to do that. Especially take advantage of it if you have like a horror-themed game or something a little bit creepy. Definitely work with the sound, right? Now, caveat: if they plug an earphone set into the earphone jack and put earbuds in, you're limited to what the earbuds will do. But the speakers work really well. I might not play the whole thing on this one, but this is about keeping holograms in place and how you lock
Early
them in
map
chairs and
makers
stuff.
would start by noting prominent physical or geological features and then fill in details by placing items relative to these markers. As the cartographer explored more and more of an area, the accuracy of the map would improve. HoloLens maps a room in a similar way. Tracking works to recognize surfaces and features of a room. When holograms are world-locked, that is, placed relative to real objects, then the holograms are anchored relative to these surfaces. As the user moves around a room, the details of a room continue to be mapped so that the placement of holograms relative to these surfaces becomes more accurate and solid. Since tracking is more accurate at closer distances, the image the HoloLens has of a room continues to increase in accuracy over time as the user moves and views room objects from various angles. You can even have multiple anchors in a world-locked scenario, with each anchor having its own coordinate system. The holographic APIs help you translate coordinates between the different coordinate systems. As the HoloLens continues to track and get better information about its environment, the translation between these coordinate systems will get more precise. Best of all, this information can be persisted, so that the HoloLens knowledge of a room can be retained for the next session or shared with another device. This opens up many possibilities to create imaginary shared worlds.
So, another thing that this spatial recognition, spatial allowance gives us is the ability to do sit-down localized experiences, room-level experiences, or literally global experiences. And you determine how big you want your world to be and where you want it to be seen. And you can have an environment or a game that spans the entire convention center, for example. If you can scan it or map it, and if you have something beforehand, it's even better. But you aren't limited to a 6-meter diameter space. And that's something that all these kind of mobile devices are really providing for us now. Did any of you guys ever play, there was a game in the 80s called Killer. And it was basically a role-playing game, kind of a live-action role-playing game, where you'd be assigned a target, and you get a picture of them, and you had to go and somehow put a tag on them or do something. And playing it at conventions was actually kind of fun because you weren't supposed to get caught doing it. Imagine doing that with some kind of device you can walk around the convention center with, like HoloLens. That would be incredibly cool. So we can take our experiences and our digital worlds and really expand them. So, sky's the limit. Now, how do we do all this stuff? We have tools that are largely pre-made for you to take advantage of this stuff. You don't have to hand code most of this. So the Mixed Reality Toolkit, there's one specifically for Unity, and then there's a Mixed Reality Companion Kit. The Companion Kit is designed for stuff off device. It's the kind of the WebB portal. It's the stuff that lets you pull the surface reconstructions off, the remote control, the remote video streaming, that kind of stuff. But the Mixed Reality Toolkit for Unity is a series of wrappers, game objects, and prefabs that wraps the Mixed Reality Toolkit that makes it a lot easier to drop these things into a Unity environment and take advantage of them. Taking advantage of spatial audio is a tick box. Making sure that your object, your holographic ball, will actually interact with the surface reconstruction and the floor and bounce off the chair is a tick box. Game object, rigid body, tick box, interact with surface reconstruction. We will handle all this stuff for you in the Windows Mixed Reality platform. So if you go with DirectX, you can certainly take advantage of it, but there's API calls you make, hand coding, instead of the drag and drop tick box stuff in Unity. Yep. Hmm? Mm-hmm. Yep. Yeah, so is it perfectly flat? It's not always perfectly flat, but the more you stare at it and the more you move around it, the more accurate it gets. Make a two triangle plane. No, it doesn't do that. That would be a cool thing for it to do. Maybe we'll take that on board. The best way to think about the visual is when you put on a HoloLens and you look at a blank wall and you tap, it shows you the mesh. It just kind of spreads out over what you're looking at. So you can get an idea of what that mesh is like. But that mesh isn't actually as accurate as the holographic placement. Let me just say. Imagine it like this. You walk into this room and you take a fire hose full of foam, the fire suppressant foam, and you spray it over everything. That's kind of what you get. But when you have something on there, the placement of the hologram and its maintaining its position will be millimeter accurate. Yes. Yes. That's right. So we've had to make some compromises. Yeah. That's right. We had to compromise on that, right? Because if we tried to do it, this would be incredibly challenging in itself because it's glass, for example. Sorry, there was a pause in the recording there. So basically all this will, oh, yeah, go ahead. Uh-huh. Yes. That's right, yep. Yeah. So, to paraphrase the question, make sure I understand it, is there a plan to take the relative distance of where your hand is in relation to an actual hologram and make that effective for touching, manipulating holograms? Yeah, you can. You could do it now, but you would have to do more coding. There's some coding things you would have to do with hand distance and position and the actual world coordinate position of the objects, make sure they match in relation to the camera, or the user is the camera. The HoloLens's view is basically a single camera scene where you are first person camera. So you can do it in relation to the camera. I've given a lot of demos, and people always try to touch it. It's pretty gross, and I do it with a holo anatomy demo, but you know, they try to touch the holograms, and the first thing I do is say, "That's cool. You can't quite touch it. It's made of light, and you can't touch normal light." And then they stop doing it. They just move on. But the controllers, manipulation with your actual hands, being able to take something and push it off a table, for example, yeah, that's very high on our to-do list. It's an important interaction that makes things more natural. So very quickly, this stuff. The feature areas that are in the Windows Mixed Reality Toolkit that you can basically drag and drop and take advantage of are these things. Input sharing, user controls, the spatial audio. That spatial understanding is pretty much tick boxes and loading SRs and using them as colliders. So you can get all of that rich interaction, map somebody's house, have your game operate in their house with the dynamic set of colliders and planes and the surface reconstruction. So we've seen that that's been pretty good. Now that boundary detection in the lower right there, that's pretty much for the IMHDs. With a HoloLens, you don't need boundary detection. You see the wall, right? But with an IMHD, because it's opaque, you need that to give you the boundaries. And you can display them as like dots floating around or a grid or something. I mean, you can just tell people don't walk there, you're going to smash your face, right? The various utilities work across all the rest of this. In fact, the spatial mapping is specific to HoloLens, and then the boundary detection is specific to the IMHDs. The only other one that's different is the spatial understanding, which is more HoloLens related than the IMHDs based on where it can move, where the IMHD can move. We've only got 84 slides to go, so we're doing fine. Build your experience. Your app experience goes on this, and the Holo Toolkit is open source. It's on GitHub. You can download it, use it to your heart's content. In fact, we even invite you to contribute to it if you want to. It will go through a sanity check process. We do read the code. Some people have tried. But please, contribute to the Holo Toolkit. And this will continue to be open source. We work with a lot of commercial customers in medical, in the healthcare industry, automotive industry, engineering industry, digital twins, remote communications. And all the things we learn is that can improve the platform we put in this Holo Toolkit. So we'll continuously be adding to this batch of open source code. So we'll continuously be getting new stuff. And then here's another one for you. Steam VR. Done stuff for Steam VR. It will work in HoloLens and all these IMHDs. There's a Steam VR player. There's even a preview for it that you can sign up for, aka.ms, I want MR. You can sign up for this. Basically, if you have an app that works in Steam VR, we'll be able to load it in HoloLens and it'll run. That's where we're headed with that. Okay. So you don't have to redo it. Got his picture. Okay. Miniature roadmap. The ones in the top box we just released about a week ago or 2 weeks ago, and then the one on the bottom one is the stuff that's coming up next. 360 video player prefab. So if you've got 360 video that you want for your background scenes or something, and while the player's interacting here, you drop that prefab in and it builds it for you, and you just give it a video source, and now 360 video is done. Okay. And then foveated rendering. Is anybody dealing with foveated rendering? Okay. Yeah. Does anybody know what foveated rendering is? Okay, good. Foveated rendering is basically where the stuff that's dead focused for the user is very crisp and clear and sharp. Things that the further you go away from their focal point, the less accurate, fewer pixels, less accurate. It's not rendered as sharply to save processing power and everything else. So it lets you do higher polygon counts with less resources by changing the focal point and not rendering stuff in a clear sharp. That's the Reader's Digest version of what foveated rendering is. Oh, good. Yeah, yeah. And the level of detail, instead of being based on zoom in, zoom out, is based on distance away from your center of focus. Yeah, this is a good way to put it. Requires eye tracking cameras, which, yeah, why don't you have eye tracking? That's a hard problem to solve right here. Yeah. I'm gonna get right to 2D apps. You can, if they're built for Windows 10, they will work in HoloLens. That just appears two-dimensional panes. For the applications and games you have now, like you could do the two-dimensional version of Minecraft, and it will run in a window in a pane. They don't have backs. So middle of the room. no concept of a back in a two-dimensional application, so you need to put a shell in it. And we're creating prefabs to shell these, and then you nest your application in the shell so you don't lose it. Or you implement, you could, a lot of calculations in that, or you could implement billboarding. So it always turns to facing. Like, do it with graphs, do it with Excel. Never thought I'd say that. Holographic apps are more immersive 3D, direct, got that. Anything else important? Use the emulator, I already beat that one to death. You don't need to use Unity if you're going to be building 2D apps. You can do that in Visual Studio or whatever else you've got. Extend your reach, localize, monetize, all this stuff you've been hearing for years in game design. Online tools and resources. Go to HoloLens.com. Click on the developer button. Everything we teach our partners from Holographic Academy, all of our training material, all the updates on the SDKs, the development toolkits are on there for free for you to access. There's tutorials. There's tutorials on spatial rendering, spatial sound, multi-user holograms, and the latest tutorials about using the controllers. Although you need Unity 2017.2 specifically for that. The latest version of Unity breaks a bunch of things, so it's wait until they fix it. Yeah, that. Do the I Want MR community. That's actually pretty cool. Buy one today. Yeah. And then we've got this. If you would like to buy one or pre-order one, including the Samsung in the lower left, which, like I said, is like the Ferrari of these devices, scan that QR code. It'll take you to a page, which is effectively the I Want MR page, and you can sign up and ask for a pre-order for these. These head-mounted devices are ranging from like $399 US for the blue Acer one up to about $850 or so, give or take. I don't know the final price for the Samsung, but the Samsung one is quite impressive. I don't know if that is still valid. 6th, November 6th. I don't know if that offer is still valid because it was specifically for the Unity conference, so we're going to go right to here. Thank you very much for hanging in there for the extra 10 minutes for me.